So, good morning, everybody. Welcome to Hydraulics and Hydraulic Machines class. We are now in Unit 4, Part 3, which deals especially the hydraulic turbines and some of the important points like specific speed, unit quantities, governing of turbines, surge tanks, selection of turbines, cavitation of turbines, cavitation in turbines, and lastly, characteristic curves. So these are the various short notes that which we have in this particular unit. So in the last class, we have completed the specific speed and some of the problems on specific speed. In today's class, we take up the unit quantities. Unit quantities are very, very important in order to predict the behavior of turbine under various working conditions. What is it? The unit quantities help for decision making to predict the behavior of a turbine under varying working conditions. Similarly, in order to compare the performance of different turbines of the same type, these unit quantities help us. So let us see how the unit quantities help us in predicting the behavior of turbine and working under various conditions. At the same time, in order to basically the facilitate the comparison of the performance of turbines of same type. Let us see that. So the today's topic is unit quantities. In this, what is the use of this unit quantities? Number one, to predict the behavior of turbine working under varying conditions. What is this varying conditions? It may be head, it may be speed, it may be output power, gate opening, etc. So these are the varying conditions. Under these varying conditions, to predict the behavior of turbine, we use this actually this unit quantities, right? The results, right, are expressed in terms of quantities which may be obtained when the head on turbine is unity, that is 1 meter, right? At the same time, the efficiency is unaffected. The second thing is to facilitate comparison between performances of same type of turbine. What are the unit quantities? What are the unit quantities? There are three unit quantities. Number one is unit head, which we represent it by n capital N suffix u, right? Second one is not unit head, sorry. The under unit head only we are trying all this unit speed, unit discharge, and third one is unit power. Please note I am talk because why I told unit head is because when the head on the turbine is unity, then we talk about these things. So that's why already the moment when I say unit speed means the speed of the turbine when the head on the turbine is equal to unity. And similarly, unit discharge is when the discharge through from the on the from the turbine or on the turbine when the head is unity. The power developed by the turbine when the head on it is unity. So these are the three unit quantities. Let us take first one, unit head. What is unit head? Sorry, again, unit head is coming because number of times. The first one is unit speed because my mind always think that head is unity, head is unity. So unit speed, it is defined as the speed of the turbine when speed of the turbine working under the head of 1 meter. So this is what we call it as the unit speed. Similarly, this is represented already. I told NU. NU is equal to N by root H. Unit speed is equal to speed divided by root H, or unit speed or comparison if you want to make it, it is N1 by root H1 is equal to N2 by root H. So unit speed is equal to Nu is equal to N by root H, which is equal to N1 by root H1, which is equal to N2 by root H2. And the other one is unit discharge. Unit discharge, it is defined as the discharge passing through the turbine which is working under again same unit head, that is head is equal to 1 meter. It is defined as the discharge passing through the turbine which is working under unit head, and this is represented by QU is equal to Q by H to the power of basically or Q by basically root H1 root H, or QU is equal to Q1 by root H1 is equal to Q2 by root H2. Why I am writing the second one is to compare actually same type of turbines, their performance. And the third unit quantity is unit power. Again, unit power is defined as again as the power developed by the turbine which is working under unit head. That is, head is equal to 1 meter. And this unit power is equal to P by H to the power of 3 by 2, or Pu is equal to P1 by, sorry, H1 to the power of 3 by 2 is equal to P2 by H to the power of 3 by 2. So these are the three things. First, you should know it. Then, if you want derivations, I will do just for your sake. One I will do. Please, rest of the things you should take care. So let us take it. Unit speed I will do. Unit speed derivation. Quickly I will go through it. So when unit speed, what is unit speed? Nu is called as unit speed. N is equal to speed of the turbine. H is equal to head acting on the turbine. U is equal to tangential velocity. V is equal to absolute velocity of jet. Tangential velocity of basically of the wheel. Absolute velocity of jet. So these are the basic things. And already we know, tell me what we know basically. U is equal to Ku root 2GH, which implies U is proportional to root H. We also know V is equal to Kf root 2GH. So which implies V is also proportional to root. So therefore U is proportional to V is proportional to root H. This is the first thing. And again, you also know that U is equal to pi d n by 60. That means actually U is proportional to n for a given turbine, right? Where the for a given turbine means D is equal to constant. Then when U is proportional to n, so naturally if these two you compare it, then what will happen actually? N is root proportional to root h from these two, right? Then when n is proportional to root h, n is equal to some k1 into root h, right? If h is equal to 1 meter, then n is equal to nu. That is the definition. So therefore, nu is equal to k1 into root 1. Therefore, k1 is equal to nu. Therefore, n is equal to nu into root h, or nu is equal to n by root h. Similarly, you can do the second thing also. Everything it is very simple that you can do it. For example, if I take it unit discharge. So unit discharge, if I take it, H is equal to head acting on the turbine. U is equal to discharge, right? A is equal to area of flow, that Q is equal to area of flow into velocity. So therefore, Q is equal to area of flow into velocity. Area of flow is basically area into velocity. And we know V is proportional to root H because V is equal to KF into root 2GH. So V is therefore Q is proportional to root H, assuming A is constant. That means for a given turbine, right? So therefore, Q is proportional to root H means Q is equal to some KT into root H. So if H is equal to 1 meter, then Q is equal to QU. Therefore, QU is equal to K2 into root 1. K2 is equal to QU. Therefore, Q is equal to QU into root H, or QU is equal to Q by root H. That is the second. So third one also I will show it for you. Be fast actually. Third one is what is unit power. What is unit power? Unit power is the power developed by the turbine when it is when a head of 1 meter is acting on it. Right? So this is again H is equal to head on the turbine, head acting on turbine, right? Then P is equal to the power developed, right? Then what you head is equal to over power is equal. Then we already know basically eta 0 is equal to P by gamma QH by 1000, where P is in kilowatts. Am I right? Fine. So therefore, P is equal to eta 0 into gamma QH by 1000. So that signifies P is proportional to Q into H. So this is the first thing. And we already know that for a given turbine, Q is proportional to root H. Therefore, P is proportional to root H into H. That is, P is proportional to H to the power of 3 by 2. Or P is equal to some K3 into H to the power of 3 by 2. Therefore, if H is equal to 1 meter, then P is equal to PU. Therefore, PU is equal to K3 into 1 to the power of 3 by 2. Therefore, K3 is equal to PU. Therefore, P is equal to Pu into H to the power of 3 by 2, or Pu is equal to P by H to the power of 3 by 2. So all three are obtained. So finally conclude it actually. What is unit speed? Unit speed Nu is equal to N by root H. Unit discharge Uu is equal to Q by root H. Unit power Pu is equal to P by H to the power of 3 by 2. These are the unit quantities. And what is the relation also to compare the performances I told? N1 by root H1 is equal to N2 by root H2. is equal to N3 by root H3 and so on. Or Q1 by root H1 is equal to Q2 by root H2 is equal to Q3 by root H3 and so on. Or P1 by H1 to the power of 3 by 2 is equal to P2 by H2 to the 2 is equal to P3 by H3 to the power of 3 by 2 and so on. So this is basically the unit quantities. Let us take one or two problems in this one. Very simple problems. A turbine develops 500 kilowatts power under a head of 100 meters at 200 rpm. What would be its normal speed and output under a head of 81 meters? Turbine develops power P is equal to 500 kilowatts. Head is equal to 100 meters. N is equal to 200 rpm. Question is, what would be its normal speed and output under a head of 81 meters? If H1 is equal to 81 meters, what is its N speed and what is its basically power? This is the question. Clear thing is N1 by root H1 is equal to N, N2 by root H2. So they using this, the original conditions are, for example, if I take it, if I call it as this way N1 H1, then I call it as H2 N2 P2. I call it like. So what is N1 is equal to 200 divided by root of 100 is equal to what is N2 is the question mark divided by root 81. Therefore, what is N2? This N2 is equal to 180 rpm. Then similarly, P1 divided by H1 to the power of 3 by 2 is equal to P2 divided by H2 to the power of 3 by 2. P1 is equal to 500 divided by 100 whole to the power of 3 by 2 is equal to P2 divided by 81 whole to the power of 3 by 2. Therefore, P2 is equal to 364.5 kilowatts. So this is a very simple problem. Like that, you can solve the problem basically. A recent gate problem, I will give it to you. Try to solve that. A hydraulic turbine, a hydraulic turbine develops 1000 kilowatts power under a head of 40 meters. If the head is reduced to 20 meters, the power developed in kilowatts is, this is basically in gate P, the same question has come. So again, let us take it. P1 is equal to 1000 kilowatts.
and h1 is equal to 40 meters. Question is P2 is equal to how much and H2 is equal to 20 meters. Solution is P1 by H1 to the power of 3 by 2 is equal to P2 divided by H2 2 to the power of 3 by 2. So it is that is 1000 divided by 40 to the power of 3 by 2 is equal to P2 divided by 20 to the power of 3 by 2. Therefore, P2 is equal to how much? Calculate. So here I will stop this lecture so that we will take another small short note in the next class.
Like, share, and subscribe. Hit the bell icon for more updates.